Alright guys, we're going to add to our table of contents. We're going to put page 61 and 62. And we're going to talk about writing our exponents in a different way. So we're going to talk today about converting exponents to root form. So I want to put a few words in our Words Worth Knowing because I think that's important as well. So in our Words Worth Knowing, we've already talked about what rational and irrational mean, I'm pretty sure. So I don't know why I don't have this written down here, but I hope you do. Rational means fractional. So if I'm writing something rationally, I'm writing it as a fraction. So we're going to be looking at exponents that are rational numbers, so exponents that are fractional, which is kind of weird, and we've had a few of those already. You probably noticed a few on your quiz. And what we're going to be doing is we're going to be rewriting them in root form. So we need to talk about what root form is, and really the more proper word for it is radical form. This chapter, I'm just saying, we had exponent rules, like are awesome, and radical form, which is totally rad. Radical form is just root form, so like a square root. So writing a number under a root. I'm not going to put square root because there are other types of roots. For example, something like this, the square root of 49, is in radical form because this little symbol right here is called the radical. However, there are also things called cube roots. They have a little 3 out front, and you can take the cube root of a number. It's very similar to a square root in so much as when I'm taking the square root of something, I think what number times itself, so what number twice, is 49, and hopefully you know that's 7. With a cube root, I just have to think one more number. So what number times itself 3 times is 8. And so hopefully it doesn't take you too long to figure out that that is 2. And that's because 2 times 2 times 2 is 8. So we're going to just mostly practice on rewriting these in the other form. So changing from exponent form to radical form. We're also going to do a little bit of simplifying as well. We'll do more of that later though. So turn to page 61 and 62. I think that's the page that we're on. We're going to put this on page 62. It's probably going to have to go sideways. No big deal. Oops. Tape. So for the most part, I think you guys recognize this symbol as the square root symbol. However, underneath my square root, I could have things with exponents. So this right up here is our exponent. I'm going to put E for exponent. And then I just showed you this little cube root thing. So sometimes you know you have the cube root of 8. So this little number right here is talking about this number on the outside. That number tells me like how many times I need to figure this number out. Like this tells me I need 3 of some number. When it's square root, so there's nothing there, it tells me I need 2 of those numbers. So if I had something like that, hopefully you understand now that that would mean I need 4 of some number. And so I'd be thinking 4 of what number would get me 16? Hopefully you can think, oh, that's 2. Because 2 times 2 times 2 times 2 is 16. That little number also has a name. We're going to put I because it's known as the index. Or sometimes I'll call it the root. Okay, this little number right here, we can do double star. We want to remember that that is called the exponent. Okay, when we take something that's in root form and rewrite it in exponent form, your exponent stays in the numerator. So this stays. Your index goes under. Okay, so we're going to try a few, just rewriting it first. Okay, so let's go to page 61. We're going to try some examples, and then we're going to practice this a ton in class tomorrow. So we're going to just first write in root radical form. Okay, so it's important to remember, just like with our exponents, we have to be careful about which exponent goes with which number. So in the first one, it's very simple because there's just one number. And so if I'm going to rewrite this in root or radical form, I'm going to put the root, and I'm going to put my a on the inside, and then I just want to make sure that I put the exponent and the index in the correct spot. So because 2 is my numerator, it stays with my a. 3, the index, goes under and it goes outside. So that's how we'd rewrite that. Now it's in radical form. Okay, similarly with b, both of these numbers are being raised to the 3/4 power. So when I write this in root form, I know my index is going to be 4, so 4 comes on the outside. And now you could write this on the inside one of two ways, keeping in mind that both of these numbers are being raised to the 3rd power. You could write it in parentheses 64b to the 3rd, or because both of those numbers are being raised to the 3rd power, you also might want to rewrite it as 64 to the 3rd, b to the 3rd, because we can distribute. So this is probably the best answer here. Okay, and then the last one, again, we have to make sure that we treat each number individually. 25 has an exponent of 1. It doesn't have a root because this is just 1. There is no denominator. So 25 is not going to go in my root. X, however, does have a root, and that's because it's fractional. And so the root is 2. You can write it or not. The exponent is 1, so you can write it or not. So I might rewrite this as 25 square root of x. Because I don't need the 2 if it's square root, and I don't need the 1 if it's to the 1st power. Okay? So now we're going to go the other way. I'm going to give you stuff in radical form, and we're going to rewrite it in exponent form. So write in exponent form. Okay, so for the first one, my number is a, the exponent is 3, it stays there, and 5 just goes under. So to the 3/5. If this fraction can simplify, you should simplify it, but it doesn't. Next one, both of these numbers are to the 4th power, so when I rewrite this, I should rewrite it 2c, still in parentheses, to the 4th power, Because there is no index, it's 2, so 2 goes under. Now that is something that I can simplify, because 4 over 2 is just 2. And then, because I have parentheses, I should probably distribute. So this is going to be 2 squared c squared, which I can also simplify to 4c squared. So that one required a little bit more work. And then the last one is a little bit different as well. Both of these things are being cube rooted. So when I rewrite this, I should think, as far as the number goes, I might want to think first, like, is there any number when I times 3 times is 27? And I know it's not 2 because 2 times 2 times 2 is 8. So maybe 3. 3 times 3 times 3 is totally 27. So 27 cube rooted is just 3. But this 3 also has to go under the 2. So this is going to be c to the 2/3. So that's kind of weird because we have to simplify that if we can. If we can't, we just leave it. And so we'll do some of those tomorrow as well. The last thing I want to do is just practice a couple of roots. And I'm just going to give them to you and have you guys try. So simplify. Okay, so the first one, I want you guys to try the square root of 81. Second one, cube root of 216. And then the last one, fourth root of 625. So try those out and we'll check them tomorrow. Have a good night.